Hello students, we have done with unit number 1. Now we will start with unit number 2. In this unit we will try to understand the basics of sources of electric power, and then we will try to understand number of theorems which is used to solve any electronic circuit. Of course, the electronic circuit will consist of either voltage source or current source. There will be number of resistances, so we need to simplify, we need to solve that circuit to find out voltage and current at different points. For that we need to understand different theorems, and before that we will start with the basics of sources of electrical power. Of course, by now, being an electronic student, you already know there are two types of source. I have written on the board. The first one is AC source and the second one is DC source. Let us try to understand what exactly we mean by AC source and DC source. I will show you first what we mean graphically, and then we will try to understand how exactly that waveforms are formed. So when I say AC source, AC means alternating cycle. It can be alternating voltage, it can be alternating current. In general we say alternating cycle. So if you draw a graph between time period on the x-axis and voltage or current on y-axis, then what happens is the waveform will look like this. So what you can see is this is the neutral, 0 point, right? Zero reference. This is the positive part and this is the negative part. That means the amplitude of the signal is changing its polarity with respect to time. For certain period of time it is positive, then it is negative, then it is positive, then again it becomes negative. So if a signal or a waveform changing its polarity with respect to time, it is called as AC. As I said, the name alternating cycle, that means the cycle will change alternately with respect to time. So there are two things to be remembered for an AC source. Of course, it is changing its polarity with respect to time. Also, its changing is amplitude. 1, 2, 3, 4. What you can see is if you change at T1, at T2, at T3, at T4, what happening is with respect to time the amplitude also is varying. Of course, it will be crest and trough. It will keep on increasing, then decrease, again increase in the negative direction, decrease in the negative direction. It will keep on happening. So the two things are there. The amplitude is continuously varying with the time period, with the time, as well as the polarity of the signal changes with respect to time. So this is all about AC source. The next one is DC source. So DC source, if you draw a graph between time period and amplitude or voltage on the y-axis, what you can see is the DC source will have a straight line. A DC source will have a straight line. That means what you can see is, you said at T1, at T2, at T3, what happens is if you check the amplitude remains constant. The amplitude remains constant. Also what happens to the polarity? This is positive, this is zero reference, this is negative. What happens to the polarity? The polarity remains constant. Either it will be in positive direction or it will be in negative direction. Okay, so the polarity as well as amplitude remains constant over the period of time for DC source. The polarity as well as the amplitude, or you can say magnitude, changes with respect to time. That will be your AC source. Example of DC source is simple. Battery is simple. Battery we use at home for most of the electronic devices which we use at home, say torch or say there are number of devices where you use batteries, remote control car, toys, everywhere you use batteries. They are example of DC source. How it is DC source, I will explain you. They are example of DC source. And example of AC source, example of AC source is alternator. This is one example. Second is, a very good example is windmill. I hope you have heard this windmill. Windmill, what it does is it converts mechanical energy into electrical energy. That is what we will try to understand, and that is how we will try to understand how it produces an AC waveform. So these things has to be understood. So both these examples are very, very important. This is in battery is an example of DC source, and alternator and windmill is an example of AC source. So now let us try to understand first how exactly an AC waveform, alternating cycle waveform is formed. If I take an example, I'll take an example of windmill because you are more related to windmill. So windmill, हिंदी में उसको बोलते हैं पवन चक्का. The fan moves, है ना, बहुत बड़े बड़े फैन लगे रहते हैं, फैन घूमता है और इलेक्ट्रिसिटी प्रोड्यूस होती है. तो दैट इज व्हाट इज कॉल्ड एज विंड एनर्जी इज कन्वर्टेड इनटू इलेक्ट्रिकल एनर्जी. लेट अस ट्राई टू अंडरस्टैंड हाउ एग्जैक्टली अ विंड एनर्जी इज कन्वर्टेड इनटू इलेक्ट्रिकल एनर्जी. In the previous chapter we have gone through a component called as inductor. Inductor is nothing but a length of wire which has been coiled over a core, which can be air, which can be ferromagnetic material, or it can be an iron core. So if such a inductor is there, if a coil is there and current is flowing through the coil, what happens is there is a magnetic field which is produced. That is called as self inductance. ये हमने पढ़ा था यूनिट नंबर 1 में अंडर द टॉपिक इंडक्टर. तो क्या होगा कि करंट जब फ्लो होगा इंडक्टर में से तो मैग्नेटिक फील्ड प्रोड्यूस होगी. सेम फिनोमेना होगा जब एक मैग्नेटिक फील्ड लिया और उसमें एक इंडक्टर रख दिया, हम उसको इलेक्ट्रोड बोलेंगे और हम वो इलेक्ट्रोड को मूव करेंगे. अगर वो इलेक्ट्रोड को मूव करेंगे तो द इलेक्ट्रोड एक्सपीरियंस चेंज इन द मैग्नेटिक फील्ड, and change in the magnetic field induces current into the coil. That is the phenomena. See, is mutual, है ना. कैसे बोला मैंने, एक इंडक्टर लिया, उसमें से करंट फ्लो किया तो मैग्नेटिक फील्ड बनी. एक मैग्नेटिक फील्ड लिया, उसमें इंडक्टर रख दिया और इंडक्टर को अगर अपन ने मूव किया तो क्या होगा, इंडक्टर विल एक्सपीरियंस चेंज इन द मैग्नेटिक फील्ड, एंड चेंज इन मैग्नेटिक फील्ड इंड्यूसेस करंट. वो उसमें करंट इंड्यूस करेगा, मतलब करंट विल स्टार्ट फ्लोइंग थ्रू द इंडक्टर. दैट फिनोमेना इज यूज्ड इन windmill. So windmill में कैसा होगा, see this is the zero reference, ठीक है, I'll take this as zero reference. So say ये जो है ये 0 डिग्री है, ये 90 डिग्री है, ये 180 डिग्री है, ये 270 डिग्री है, ठीक है. सो नाउ व्हाट हैपेंस इज, ये हमने जो इंडक्टर रखा है मैग्नेटिक फील्ड में, इट इज एट 0 डिग्री. नाउ व्हेन इट मूव्स फ्रॉम 0 to 90. सी व्हाट हैपेंस इज, है ना, ये जो 90 डिग्री और 70 डिग्री है, यहाँ पर हमारे मैग्नेटिक लाइन ऑफ फोर्सेस है. तो अभी हम लोग कहाँ मूव कर रहे हैं इंडक्टर को, इंडक्टर इज मूविंग फ्रॉम 0 to 90. तो जब वो 0 से 90 पे मूव कर रहा है, इट इज मूविंग टूवर्ड्स द मैग्नेटिक लाइन ऑफ फोर्सेस. और जब वो मैग्नेटिक लाइन ऑफ फोर्सेस के तरफ जाएगा, करंट जो इंड्यूस होगा इंडक्टर में, दैट विल कीप ऑन इंक्रीजिंग, दैट विल कीप ऑन इंक्रीजिंग. और ये जो मैग्नेटिक फील्ड की तरफ जा रहा है, इट इज कटिंग द मैग्नेटिक फील्ड इन पॉजिटिव डायरेक्शन फ्रॉम 0 to 90. So 0 to 90 it is cutting the magnetic field in positive direction and it is moving towards the magnetic line of forces. That means the current induced will increase in positive direction. This is the part. So if I say current, so current with respect to time, the current will increase from 0 to 90. At 90 it will reach its maximum value. It will reach its maximum value. Now from 90, now what happens is it is moving from 90 to 180. So it is moving away from the magnetic line of forces, but still cutting the magnetic field in positive direction. As it is moving away from the magnetic line of forces, current will decrease, but decrease in positive direction. So it will decrease like this, So this point is 180 degree. This is the point when it is moving from 90 to 180. Next, 180 to 270. So when it is moving from 180 to 270, see what happens is, again it is moving towards the magnetic line of forces. 180 to 270, it is moving towards the line of forces, but it is in the negative direction because it will cut the magnetic field in negative direction. So it is increasing as it is moving towards the magnetic line of forces. The current will increase, but in the negative direction. So, and it will reach its maximum in negative direction at the point 270 degree. And of course, when it is moving from 270 to of course 360, it will come back to its initial condition, that is 0 degree. 272, it is moving to 0 degree. It is moving in negative direction, but it is moving away from the magnetic line of forces. So current will keep on decreasing in negative direction. The current will keep on decreasing in negative direction. So this is 360 degree, or it is, we can say that it has reached the same point. So what happens is, there is a shaft, fan is there. In windmill there is a fan, right? So fan is connected to a shaft, and in shaft there is a coil. That means shaft acts as a core, and over that there is a coil which has been wound, and this coil is kept in a magnetic field. So when the fan moves, the shaft moves, the shaft moves, the coil moves, the coil moves in a magnetic field, and it experiences change in the magnetic field. And if it experiences change in the magnetic field, the change in the magnetic field will induce current into the coil, and current will produce like this, a sinusoidal waveform. This is called as sinusoidal waveform. Sinusoidal waveform. Sinusoidal waveform, because it depends upon the sine angle, 0, 90 degree, 180 degree, 270 and 360 degree. So the movement of this fan is continuous, and therefore a continuous AC signal will be produced. It is changing its magnitude as well as polarity with respect to time. Therefore we say that it is an AC signal. So example of AC signal is alternator and windmill. I hope you have understood how exactly an AC waveform is produced. Next is the DC source. As I said, the example of DC source is battery. So a beaker is taken. Battery is nothing but group of cells. So I'll just explain you what exactly one cell means. We take a beaker and we pour electrolyte, generally a diluted sulfuric acid, H2SO4. So this is what is your electrolyte. Okay, and in this electrolyte we immerse electrodes of two different material. These are electrodes. Now what happens is, as soon as you immersed electrodes in electrolyte, a process called as electrolysis happens. In electrolysis, all the positive charge accumulate on one of the electrode, and all the negative charge accumulate on the another electrode. Okay, so one electrode is completely positively charged and one electrode is completely negatively charged, and if you connect between these 2 points, if between these 2 points we connect a load, say any electronic circuit which needs external power supply to work, what happens? Current will flow from positive terminal to negative terminal. It will energize the load, but the direction of the current will remain same, only one direction. It will move from positive to negative, so direction of current remains same, and the magnitude also, the magnitude means the amplitude of the voltage source will also remains the same. So that type of source which produces such an arrangement is called as DC source. So this is what is the basic idea of sources of electrical power, which is AC and DC source. I hope you have got a slight idea about what I am trying to say. Next, we will try to understand concept of impedance. It's very, very important with respect to the circuits which we are going to understand later. Concept of impedance. See, impedance, if you remember, we try to understand in the first unit, we try to understand resistor, capacitor, inductor. What is resistor? What is the property of resistor? Resistor's property is resistance. And what is resistance? Resistance is the opposition to the flow of current, right? And I already said that whenever you design an electronic circuit, we use number of components. For example, the components which you know is resistor, inductor, capacitor, transformer. Then we have semiconductors device like diode, transistors. See, so an electronic circuit is made up of all such components, and all such components oppose flow of current. So the overall opposition to the flow of current is called as impedance. Okay, so what is impedance? It is the total opposition to the flow of current in an electronic circuit. So what is impedance? Impedance is the total opposition to the flow of current in an electronic circuit. And I have explained you, and this total opposition is because of the component which is used to design that electronic circuit, such as resistor, capacitor, inductor, transformer, switches, diodes, transistor, etc. It can be anything. Now we are trying to understand this impedance on the basis of the sources which we have studied now. कौन से दो source पढ़े हमने? Sorry, AC source and DC source. So now to design AC source, as I said, the example of AC source which we took is windmill, and windmill is the basic circuit which is used in windmill is called as armature winding. Okay, it is called as armature winding. What I said, it's nothing but a length of wire, a shaft on which a coil has been wound. That is what is the basic arrangement. So that armature winding consists of a core over which a coil has been wound, right? So that is what is the basic structure. So now when you design an AC source, what is the component which you are using? You are using a coil and a core. Coil has its own resistance, core has its own resistance. So the total resistance offered by coil and core will be the impedance of the AC source. And DC source is made up of electrolyte, electrodes. So the total resistance offered by electrolyte and electrode the total resistance offered by the electrolyte and the electrode is called as impedance of DC source. So if you want to understand what exactly we mean by impedance, so how can you relate? It is nothing but the total opposition to the flow of current in an electronic circuit because of, now that is what we have understood, because of the component used, in that particular circuit, or in that particular, if you are talking about source, in that particular source, because the impedance is because of core and coil in case of armature winding, and in case of DC source the impedance is because of the electrolyte and electrode, which is nothing but, impedance is nothing but the opposition to the flow of current. It is nothing but a resistance, but overall resistance because of the component used in the circuit. So let us take one example and try to understand what exactly this impedance affects the electronic circuit, how this impedance affects the electronic circuit. Let us try to understand. So suppose I have designed a source, say of 4 volt. Okay, so we have designed AC or DC source. Let us I have taken an example of a DC source, positive, negative. So we have designed a DC source of 4 volt. Of course, when I design a DC source, okay, DC source is what? Example is battery. Battery is a group of cell. For designing one cell, I will need electrolyte and electrode, and group of cells will have group of electrodes, and of course the number of large amount of electrolyte. So all these components will produce opposition to the flow of current. That means impedance. That means there will be some opposition to the flow of current, that is called as impedance of the source. We denote by Ri. Ri indicates internal impedance of the source, or in other words we can say internal resistance of the source, say Ri. And let's say to the source we have connected a load. We call it as load resistance. I will denote it by RL. When I say load, it can be any electronic circuit whose overall resistance will be denoted by RL. Okay, so I have designed a source. Every source which I design will be made up of some components, and because of that component it will have impedance, and I will denote that impedance as Ri. And when I connect that volt source to the load resistance, see what happens. Okay, now say the total current flowing in the circuit be I. So what is the total current formula according to Ohm's law? Ohm's law, V is equal to IR. I is equal to V by R. So I will be V upon, and the overall resistance in the circuit is Ri plus RL. Okay, internal impedance of the source, of course, and the load resistance which has been connected, across which we will take the output voltage. Okay, we will take the output voltage. So I is equal to V upon Ri plus RL. Let's say RL is equal to 0.85 ohms and Ri is 0.15 ohms. So substitute the value. I is equal to 4 upon 0.85 plus 0.15. So I is equal to 4 upon 1, which is equal to 4 amperes. So current in the circuit is 4 amperes. Now you will take the output voltage. Output voltage will be taken across RL. So output voltage will be, of course, the current flowing through the circuit multiplied by RL. And as the two resistors connected in series, current remains same. So V0, that is output voltage which we have taken across RL, it will be I multiplied by RL. So what is I? We have calculated just now, 4 amperes, multiplied by what is RL? 0.85. So how much this value will be? This will be 3.40 volts. 20, 0, 2, 32, 34, 3.4 volts. We have designed a source of 4 volt, but when we connect a load to the source, how much we are getting at the output? 3.40 volt. So there is a drop of how many volt? There is a drop of 0.6 volt. So there is a drop of 0.6 volt, and it is because of, you have to understand that it is because of, see what is happening is, when I say RL is 0.85 ohms, that means the output voltage which we are getting is 3.40. That means this 0.60 volt is getting dropped across Ri. some voltage will be dropped across Ri, some voltage will be dropped across RL, and in this example the voltage drop across Ri is 0.60 volt. So what is Ri? Ri is nothing but the impedance. Impedance is what? Impedance is the resistance offered because of the component used to design the source. That means every source will have the impedance. If the impedance will be there, some voltage will be dropped across the impedance, and you will never get the entire output voltage across the output. So this is the disadvantage of having impedance. So this is what is the objective of understanding concept of impedance. So if there is impedance, some voltage will be dropped across that impedance, and if the voltage will be dropped across impedance, you cannot get the entire source voltage at the output voltage. I hope you have understood.